Have you ever wondered how a mere disturbance in the ocean turns into a monstrous tropical cyclone capable of wreaking havoc on a massive scale? Welcome to the enigmatic world of tropical cyclones, colossal storms born from the sea and fed by the sun's energy. They go by many names worldwide: hurricanes in the Atlantic and Northeast Pacific, typhoons in the Northwest Pacific, and simply cyclones in the South Pacific and Indian Ocean. These natural phenomena are a blend of beauty and terror, fusing the raw power of nature with its intricate complexity. Each cyclone is a unique beast, churning with winds that can exceed 100 miles per hour and unleashing torrents of rain that can lead to catastrophic flooding. Their formation, their life cycle, their impact, each aspect of a tropical cyclone is a fascinating puzzle piece in our understanding of Earth's dynamic weather patterns. So, buckle up and join us as we unravel the mysteries of these awe-inspiring yet perilous forces of nature. A tropical cyclone doesn't just pop into existence, it is born out of specific conditions. It's like a dramatic dance of nature where the ocean, air, and wind all play lead roles. Let's start from the beginning. Picture a tranquil ocean, a vast stretch of blue. But lurking beneath its serene surface, there's a disturbance brewing. This disturbance is the first step in the birth of a cyclone. It's a bit like a ripple in a pond, a potential sign of something much bigger to come. Now, a cyclone needs fuel to grow, much like a fire needs wood. The fuel for a cyclone? Warm sea surface temperatures. These temperatures, usually above 26 degrees Celsius, heat the air above the ocean. This warm air rises, creating an area of low pressure beneath, but the story doesn't stop there. The air's moisture is crucial too. As the warm, moist air rises, it cools and condenses to form clouds and rain. This process releases heat, known as latent heat, which warms the surrounding air, causing it to rise as well. This creates a self-sustaining cycle, a heat engine if you will, driving the storm's growth. However, a storm needs more than just a heat engine to become a cyclone. It needs the right wind conditions. In the absence of strong wind shear, the storm can maintain its structure and continue to intensify. Wind shear is the change in wind speed or direction with height. It can tear a developing storm apart, preventing the birth of a cyclone. So, we have our disturbance, our warm sea surface, our moist air, and our wind conditions. Together they create a spinning mass of clouds and thunderstorms, a tropical cyclone. This cyclone continues to grow, feeding off the warm sea surface and moist air, growing stronger and larger until it reaches its mature stage. And thus, a powerful tropical cyclone takes shape, ready to unleash its fury. The birth of a cyclone is truly a testament to the incredible, albeit often destructive, power of nature. A cyclone is more than just a swirling mass of wind and rain. It has a complex structure that contributes to its power. Now let's delve into the anatomy of a cyclone to understand this raw force of nature better. First, picture a cyclone. It's not just a random whirl of wind and water. Instead, it's a highly organized system with a clear structure. The backbone of this structure is composed of three main parts: the eye wall, and the rain bands. Let's start with the eye of the cyclone. This is the calm center of the storm, often misinterpreted as the end of the cyclone due to its eerily serene conditions. The eye can be anywhere from 5 to 40 miles in diameter. However, don't be fooled by the calmness, because surrounding the eye is the eye wall, the most dangerous part of the cyclone. The eye wall is a ring of towering thunderstorms where the most severe weather occurs. Here you'll find the strongest winds, the heaviest rain, and the most extreme upward motion of air. This is where the cyclone's energy is focused, and the destruction can be devastating. Finally, we have the rain bands. These are bands of dense clouds that spiral outwards from the cyclone's center. They are responsible for the torrential rains typically associated with cyclones. The rain bands can extend hundreds of miles from the center and often contain severe weather conditions, including tornadoes. Each of these parts, the eye wall, and the rain bands, work together to form the tropical cyclone. They interact in a way that allows the cyclone to sustain itself and even intensify. The energy and water vapor from the warm ocean surface feed the cyclone, while the rotation caused by the Earth's rotation gives it its distinctive spin. In summary, a cyclone is a highly structured, powerful system. It's not just the wind and rain that make it powerful, but its anatomy that contributes to its destructive capabilities. A better understanding of this anatomy can help us predict the cyclone's path and potential impact, ultimately saving lives and property. Knowing the anatomy of a cyclone helps us understand why they are so destructive. The arrival of a tropical cyclone is a terrifying event, leaving a trail of devastation in its wake. When a cyclone makes landfall, it brings with it a host of destructive forces. Among these are heavy rainfall, powerful winds, storm surges, and widespread flooding. Let's start with heavy rainfall. As the cyclone moves over the ocean, it draws up vast amounts of moisture. This moisture is then released as torrential rain when the cyclone hits land. The deluge can last for days, drenching everything in its path and causing rivers to overflow their banks. This often leads to severe flooding, which can wash away homes, roads, and entire communities. Next, we have the cyclone's fierce winds. These winds can reach speeds of over 100 miles per hour, strong enough to uproot trees and topple buildings. The wind's reach isn't just limited to the cyclone's path either. The strong gusts can extend hundreds of miles from the cyclone's eye, affecting a much larger area. Then there's the storm surge. This is a rapid rise in sea level that happens when a cyclone pushes a wall of ocean water towards the coast. The surge can be several feet high and can extend miles inland, causing catastrophic flooding. It's often the most deadly aspect of a cyclone, especially for coastal communities. But the impact of cyclones isn't just felt in the immediate aftermath. They can cause extensive damage to infrastructure, such as power lines and communication systems, leaving communities cut off from the rest of the world. The environment also suffers, with ecosystems disrupted and wildlife displaced. The economic cost can be staggering, running into billions of dollars. Recovery can take years, sometimes even decades, but the human cost is immeasurable. Lives are lost, homes are destroyed, and communities are left to pick up the pieces. The aftermath of a cyclone is a stark reminder of nature's power and unpredictability. As we face the reality of a changing climate, understanding these storms and how to mitigate their effects has never been more critical. While we cannot prevent cyclones, we can take steps to mitigate their effects and protect ourselves. This is our mantra when it comes to dealing with the force of nature that is a cyclone. So, how exactly do we do this? Let's delve in. One of the most critical elements in cyclone mitigation is the early warning system. These systems, thanks to advancements in technology and meteorology, can predict the path and intensity of a cyclone days in advance. This valuable time allows communities to prepare, governments to mobilize resources, and individuals to secure their homes and belongings. But what good is an early warning if people don't know what to do when they receive it? That's where evacuation plans come in. These are detailed instructions on where and when to evacuate, the safest routes to take, and what to do if you're unable to leave. Regular drills are carried out to ensure everyone knows their role. It's like a choreographed dance where everyone knows their steps and moves in unison to the rhythm of safety. And speaking of safety, let's talk about building designs. Engineers and architects are constantly innovating, designing structures that can withstand the powerful winds and torrential rains of a cyclone. These include features like reinforced concrete, aerodynamic shapes, and elevated platforms to protect against storm surges. However, all these measures would be futile without community preparedness. It's the collective effort of every individual in the community that truly makes a difference. This involves everything from attending community meetings, participating in drills, helping neighbors secure their homes, to sharing resources during the aftermath. Remember, cyclones are a force of nature, unpredictable and powerful. But with early warning systems, evacuation plans, resilient building designs, and a prepared community, we can significantly reduce their impact. Together, we can weather the storm and come out stronger on the other side. Let's not forget, we are as resilient as nature is relentless. Tropical cyclones are a testament to the awe-inspiring power of nature. We've journeyed through the birth of these atmospheric phenomena, delving into the warm, humid air over tropical oceans that serves as their cradle. We've dissected their anatomy, from the calm eye at the center to the swirling bands of thunderstorms that make up their formidable structure. We've witnessed the impact of cyclones, a stark demonstration of nature's fury that can lead to catastrophic flooding, damaging winds, and destructive storm surges. But we've also seen the resilience of communities, their preparedness and adaptation strategies that mitigate the effects of these storms. We've learned that understanding cyclones is not just about appreciating the raw power of nature, but also about recognizing our own role in the face of these forces. It's about safeguarding our homes, our loved ones, and ultimately, our planet. Understanding tropical cyclones helps us appreciate the forces of nature and reminds us of our responsibility to protect ourselves and our planet. We hope you found this video informative and interesting. If you did, and you've learned something new about tropical cyclones, Don't forget to hit that like button. It not only supports us, but it also lets us know that we're providing valuable content that helps you understand the world around us. We're passionate about creating content that educates and engages, and if you want to be a part of our journey, we invite you to subscribe to our channel. By subscribing, you'll have access to more videos like this one, and together, we can continue exploring the fascinating world of natural phenomena. Thank you for watching. Your support means the world to us, and inspires us to keep bringing you quality content. Remember, knowledge is power, and the more we understand about our world, the better equipped we are to protect it. Stay safe and stay curious.